So, hello everyone, welcome again to my YouTube channel. And today I'm going to solve a new question from our top interview 50 question series. And this question title is Merge two sorted lists. So, this is a question from linked list part. And in this question, what we have given is that we've been given two sorted linked list L1 and L2. And what we need to do is that we need to merge these two sorted linked list and we have to create a new sorted linked list, which is got by merging these two given linked list. So this is the question which we have to tackle, that we have to create a new linked list out of these two given L1 and L2 linked list, and it should be sorted. Now let's understand the approaches and algorithms by which we can solve this question. So here you can see that I have taken the example from the question, and here you can simply see that how it has merged these two linked lists and created a new linked list which we have to return. Now how we can solve this? So first think what we have. So we have the starting position of both the lists. That means we have L1 and we have L2. That means we have head of both the linked list. Now using this two head, how we can solve? So the first approach which we going to came to in mind is that why not create a new linked list? So we are going to do the same. We are going to take this space complexity. That means we are going to use the space, and we are going to create new linked list, and we are going to insert the values in that node, and we are going to create a new linked list out of the given two linked list. So first we will start by taking a dummy node. So this is going to be our dummy node, and this dummy node you can take it as value as 1. Now after this what we can do, we can start comparing the values in both L1 and L2. So at first you will check that we have 1 1, that means both are equal. So you can take any value. So we are going to take a value 1, you can take any one. So we are going to take L1 value, that means we are going to take this one value. So we are going to create a new node and we are going to insert 1 in this by taking the value of L1 value. And next what we'll do, we will make the D next, that means the dummy next, pointing to that our temp or you can say newly created node. Now after this, what you will do, you will move your L1. That means your L1 will now move on to the next. That means this is our new L1. So this is our new L1. Now again what you will do, you will check L1 and L2. You will see which one is smaller. You will get that L2 is smaller with value 1. You create a new node and you will insert 1 into it. And again what you will do, you will point the dummy next or you can say current next. You can take another pointer which is going to be current, which is going to be moved through all our nodes. So this is going to be our current pointer and this is going to point to the next. So that's how we'll do is that by following this approach you will get all the values in order, that means in sorted order. You are able to create a new linked list having the values of list 1 and list 2, and it is also sorted. So by this approach you can simply merge these two and you can return the head, that means dummy next. So dummy next is going to be head of our output or which we have to return. So this is the first approach by which we have used a space, and we have solved this question. Now next what we are going to do is that we are going to think of a approach by which we can reduce this space complexity or you can remove this, because here you can simply see that this question example is already giving the hint to you. Here the color of the nodes you can see that what it has done, that first it has taken the this L2, then it has taken L1, then it has taken this value, then it has taken this one, next this value, next this value. So how did it do done that? So what it is done, that it has pointed the next of this L2 to this one. Next what it has done, it has already moved to L2 this, next it has moved to this, next it has moved to this, next it has moved to this. So by following this, what it has created is that created a new linked list by breaking and creating new nodes or you can say links between nodes, and it has achieved this new node, new linked list. So we are going to do the same and we are going to create a new linked list by applying some condition. So let's see how we can do this. So what we have, so we already have two pointers, that means we have L1 and we have L2. Now what we have required in the end of this algorithm, that we required the head. By previously we have taken a dummy which is going to give us the dummy next as our output head. Now here to take that head we have two situations. Either this L1 starting index, that means this L1 head going to be our output, or this L2 head is going to be our output. So first, before starting any approach, we will simply check the values of both L1 and L2 and we will decide where our head is going to lie. So here you can see both the values are 1 1, so you can take anyone as head. So we are going to take this one as our head, so we will simply appoint a new pointer ns to it, which we will return in the end of the algorithm. Now, what we have is that this L1 and L2 is going to traverse in this both L1 and L2. So these two are not going to help us to link the nodes. That means it is going to L2 is going to move in this nodes only. So we need a new node, new pointer, which is going to point this value to the L1 or L2 or this value to this value. So in order to make a relation, or you can say make a connection between nodes in L1 and L2, we need a new pointer. So for that, what we are going to do, we are going to take a new pointer which is going to be current. So let's take a new pointer which is going to be a current pointer. We are going to take it as C. Now we will start our traversal, and here you can see that we have already decided our head pointer. So it has been decided. So after deciding this, you also have to move your pointer which is already exists. So if you decide L2 to be our answer, that means the head pointer. So we have to move L2 to the next node, or if you decide L1, so you will move your L1 to the next, because it is already decided. Now what we have to do is we have to point this head pointer, you can say C pointer, added to this pointer or added to this pointer. We have two options, either move to this L2 or either move to this L1. So how will decide where to move? So values of this L1 and L2 is going to decide. So here you can simply see that the value of our L1 is smaller than L2. So what it is going to do is that it is going to point the C next to L1. So your C next is going to point to L1. After pointing this, we are going to move our L1 to this next node. So our L1 is going to point to this one. And after this, we have to also move our C pointer. So we also move our C pointer to this position. So this is the first move which we have completed, or you can say first loop which has been completed. After this, we will do the same thing. That means we compare the value of L1 and L2. Here you can again see the value of L1 is smaller, so it is not going to move anywhere. So it is simply going to again point to C next is going to point to L1. So your C next will be point to 2, and after this, what you will do, you will simply move your L1 and you will simply move your C. So now your C will be pointing to 2, your C will be here, and your L1 will be here. Now after this, second loop is complete. Next what we have L1 4 and L2 3. So your clearly your L2 is smaller, so our C will now move or point to L2. So we will again point our, sorry, it will not, it will be L1. So again what we have pointed our C to 3. So now again we have moved your C to this position, and your now again your L2 will be moved, because this time L2 has been chosen. So now L2 will be moved to this next position, that means L2 next. Now we have at the end, that means we have L1 at 4 and L2 at 4. Again these two are simple same, so either you can stay at this position or you can move at the upper end. So let's assume that you are staying at the L2. So if you are staying at the L2, that means now what we have to do is that we have to move your L2 and C. So we will move our L2 and C. So this will be removed, and your now C will be pointing to this, and your L2 will be pointing to null. So here we have null, and it is been pointed by L2. Now, so we will stop at this position, because whenever you find L2, what we need to do is that simply only the list which we have been got, or maybe it has been over like this. So next which we have been left is going to be the next list. Either this is going to point to null or this is going to point to null. So if anyone is going to point to null, simply what we do, we will simply point your C next to the next one. That means the other one list. Here L2 is null, so we will point our C to L1. So your L1 is now been pointed to L1. So your L, this is going to be pointed to this, and you will move your C. So here your C will be this position. And what we'll do with L1, so L1 we cannot we are not worrying about this, because now we already see that your L2 is already 0. So the only list which is left is L1, and it is already sorted. So this is going to give us the correct answer. So this is the overall loop or you can say overall iteration or algorithm which is going to we are going to follow and translate into code. Now let's do the coding part and understand how we can convert this algorithm in a code. So what we can do is that we can first check that if our list one is null, that it means if it is not equals to it is null. So what we have to do, we have to simply return L2. It means list 2. Similarly, if our L2 is null, we can simply return list 1. Because if anyone is null, then the next is going to be our output. So we do not need to worry. So we have simply tackled this condition. Now next what we are going to do is that we are going to take a list node, and this is going to be our current, which is going to move in our list, which we have taken as C in our algorithm. So this C is going to let point initially to list 1. So we have initially positioned or pointed it to list 1. Now we will check condition, which is going to be our primary condition, which is going to decide where our answer pointer is going to allocate. That means where our head is going to point, L1 or L2. Now here what is the condition which we can check, that if our list 2 is less than, you can say list 2 value is less than or equals to list 1 value. So if this is the condition, you can either take greater than equal to or simply take a less than equals to, it doesn't matter. So if our list 2 is less, that means what we'll do that if we have taken our C as list 1, so what we have concluded that our list 1 is smaller. So if we can find that our list 2 is smaller, then what we have to do, we have to update our C pointer. So we will update our C pointer to list 2. Now, after this, that we have already pointed our, that means we have decided where we have going to start. Now we have to move our pointer, which is now pointing to that position. That means here we have pointed to list 2. So we will move our list 2 is equals to list 2 next. Now in else part, in else part what we have that we have already know that list 1 is smaller, and this is also going to the same condition. So we do not need to do anything for C because it is already pointing to list 1. We simply need to move our list 1. So we are going to do list 1 is equals to list 1 next. Now next what we can do, we can take our answer pointer which is going to point to our current. So this is our answer pointer. So after this, we are going to run a while loop, and this while loop is going to run until we find a null value. That means until our list 1 exists and our list 2 exists. So until this, we are going to check again the same condition. So let's copy this. So let's assume you find that your list 2 value is less. So if you find that your list 2 value is less, so what we need to do is that we need to point our C pointer to list 2. So we'll point our C pointer C next will be equals to list 2. And after pointing this, that means we have found that list 2 is less. So we have to also move our list 2 pointer. So we will again do list 2 is equals to list 2 next. Now in else condition, so it is the opposite of this. That means our C next will be now point to list 1, and our list 1 will be moved to the next position. List 1 next. Now what we have to do is that we have to also move our C pointer after every iteration. So we are going to move our C is equal to C next. So we have completed our while loop and we have stopped until we find our list 1 is null or list 2 is null. Now what will happen that either of them is not null. So we are going to check for that also. So list 1, if our list 1 exists, so what we have to do that we have to simply make our C pointer next point equals to list 1. Here it is list 1. So if our list 1 exists, that means our C pointer should point to list 1. We can simply take it as here. Now in else condition, because either of them is going to be definitely null, So it is going to be else. So if else, that means we have to point our C next. We have to C next to list 2. After this, what we can do, we can simply return our answer, which is going to be our head one. Now let's run this code. So this is accepted. Now let's submit this. So this is successfully submitted. So this is a question for today, and this is a very interesting question to understand and visualize the linked list and understand it better. Now in the same video, you are going to see the code for both Java and Python. So stay tuned and let's meet in the next video. Till then, keep learning and exploring. So thank you all.